Printing a Future to Medicine by R. Vaishali and Suhasan. Introduction. 3D printing gives each consumer the freedom to manufacture his needs and improvise it. It provides endless options and freedom to the consumer. It also gives the power to the consumer to innovate new ideas. It's a boon to the field of medicine, pharmacy. It cuts complexity, cost, and inaccuracy. To study brain, the working of the brain is more often not realized by humans. Diseases like paralysis, Alzheimer's, Parkinson's can be understood better if the brain was analyzed in depth. This was made possible by 3D printing a brain model for a reformed and clearer picture and an entirely new outlook in understanding brain functioning. The scientists use a substance made by bacteria that is used as a bioink and is combined to develop brain cells by a layer printing approach. This provided a better understanding of neural functioning, which proves vital in curing brain disorders. In biomedical engineering. 3D bioprinting is a rapidly growing trend that can produce body parts that need to be replaced as it allows tailoring of the parts in the required dimension, shape, and is of relatively low cost. Researchers in Sweden use a bioink formulated of nanofibrillated cellulose and alginate. Printing with this bioink allows the cells to grow smoothly and uniformly across the structure. This bioprinting allows for simplicity for the otherwise tedious procedure to manufacture biomaterials of specific shape, size, and texture. Some of the organs which can be printed are ears, living cells, valves, bladders, and so on. Prosthetic applications of 3D printing. Implants and prostheses can be designed in any imaginable shape and size by translation of X-ray, CT scan, and MRI to digital 3D files. These 3D files are used to print the surgical implant or prosthetic limb in real life using bioink and biomaterials. Implants and prostheses are used in the fields of dental, spine, and hip joints. Such printed materials are produced at a very quick speed, sometimes within just 24 hours. Customization of drugs using 3D printing. Complex drugs can be manufactured by 3D printing in a simplified way and make it more viable. Advantages include accurate control of droplet size and dose, and to produce dosage forms with complex release profiles. 3D printing also allows for personalized drug forms. Patients who suffer multiple chronic diseases can have their medications printed in one multi-dose form. Availability of single tablets with multiple doses can increase the patient's compliance. How 3D printing works. You start by designing a 3D object on an ordinary home PC, connect it to a 3D printer, press print, and then sit back and watch. 3D printing process turns a whole object into a thousands of tiny little pieces, then makes it from bottom up slice by slice. Those tiny layers stick together to form a solid object. Each layer can be very complex, meaning 3D printers can create moving parts like hinges and wheels as part of the same object. You could print anything which you can program into the computer. The options are endless. Advantages of 3D printing. 3D printing allows personalization of medication for individuals and allows the patients to get a tailored healthcare that adapts to their body precisely. Manual fabrication in lab is a very complicated procedure and the accuracy is minimal. 3D fabrication fills up the void in accuracy and simplifies the whole procedure, which is very vital in healthcare. 3D printing can cut down the required intake of multiple medication by fabricating a single pill with all the required dosages. The conventional tissue engineering approach is not capable of creating a complex vascularized organs. 3D bioprinting shows promise in resolving this critical and grave limitation. Problems of 3D printing. 3D printing might be cost effective, but it's still expensive for the common man. So, this boon is a bias treatment. 3D printing can result in ethical issues where consumers use it illegally at private labs where they perform personal illegal experiments which can have harmful consequences. With 3D printing, humans can provide themselves with superhuman abilities by modifying their bones and tissue structure, which is against the nature cycle. Bioprinted compound and complicated 3D organs require an accurate and explicit multicellular composition with vascular network incorporation, which is yet to be achieved. Conclusion. 3D printing has become an essential and potentially transforming tool in medicine as the printer performance, resolution, and convenient materials have increased, so have the applications. The medical advances that have been made using 3D printing are already significant and revolutionary. 3D printing has varied applications like that of implant surgery, cosmetics, prosthetics, pharmaceutical, etc. The process is simple, painless, and effortless as far as manual work is concerned. While fabricating the printed product, it totally eradicates human error and opens doors to perfect and flawless fabrication. It can change the face of medicine. Thank you.